I believe if I had the main takeaway from the session, it would be that cybersecurity is an effort that has to be embedded across the organization. The security team can't ensure the products delivered to the customer are are complete. It must be through the software people, the development, the hardware engineering team, the regulatory team, the quality team, and even the product management organization. It's a multi-cross-functional team that must be in place to ensure cybersecurity is there. But the security team can provide that technical expertise and guidance to help the products meet the security requirements for the organization that are delivered to the patients and hospitals. So I believe the companies struggle in one, understanding that the bar and the requirements is not static. Unlike safety, where it has to be safe for the patients, the security requirements and technology is constantly evolving. And I know with engineering and product organizations, that can be a source of frustration because what was good enough a month ago or 6 weeks ago or even a week ago may not necessarily be good enough for the next release or the next version. Regulatory agents, whether it's in Europe, Asia, and the United States, are constantly raising the bar up, and the best practices for security is constantly evolving. So I think it's that constant evolution of requirements, best practices, and changes that companies will struggle with, and they do on a weekly day basis. Working with the teams, it's a collaborative approach. It's a team approach. The security team brings expertise, especially the product security team, because as you'll saw from the presentation, or we'll see from the presentation today, security regulations are immense. In some ways, the team is actually doing more than just medical device security. There is also security regulations for the operations in the cloud. So if, in addition to the on-premise devices that meet a set of security requirements, we also have a set of cloud security requirements. And these include items like C5 in Germany, FedRAMP in the US for the US government, SOC 2, in addition to what the FDA provides. In addition, I think the struggle is with, the IT side of the organization. IT security and product security are complementary, but they're also very different with different focuses, different objectives. And IT security has also a very broad range of regulatory requirements that must be done for a business to be successful and be able to enable a business to compete in a specific marketplace. AI is having a drastic change. If you just watch the news, you'll see the news with new technologies and companies coming out. And with AI, we must focus on 3 areas. I'm not going to go into the fancy agentic and all the terms, but fundamentally, AI is used, one, with data. And protecting the data, preventing data poisoning in the AI models is important. Second key focus area for AI within security is within the development cycle. There's been several studies on how large language models have actually compromised the open source code up to 40 to 60%, depending on the different white papers that are available. And those are actually in my reference slide, so I encourage people to look at that. So with 40 to 60% of open source code, securing and being able to evaluate the code effectively to put out secure products is important. And finally, on the threat side, AI, as I pointed out in the presentation, is actually being used to target companies. With AI, metrics that just came out this morning that I was reading, actually has decreased the attack time from a vulnerability being disclosed to being used in a real attack to approximately 20 hours, which is unheard of compared to where we were 2-3 years ago. And the bad guys are actually using AI to write the compromises and write the attacks. So across the board, AI is both an enabler to improve efficiency and at the same time a threat that we in the medical device community must be conscious of as we design the protections into our devices. So I see the greatest risks in basically when it's deployed and then in the total life cycle. A product that is put out the door, day one released, receives all of the necessary regulatory requirements, is viewed to have a reasonable and acceptable level of security. That's the definition the FDA uses for their risk evaluation. But the device doesn't stay static, and the security environment does not stay static. And being able to maintain it over the total product life cycle becomes kind of that critical item that can't be forgotten. Just because a product is good day one does not mean it's going to stay stable throughout the intended use and life cycle of the product. And as it goes through that intended use, many products will have the 5, 10, 15-year deployment time frames that are of intended use. And being able to do those midterm life upgrades when software goes end of support, end of life, especially from third-party products, actually becomes critical in terms of protecting the world around us and protecting the hospitals and customers. I have been surprised. I mean, I keep learning new items. I don't come from a medical background, so to hear, the first opening keynote on the evolution of surgery was actually kind of impressive to me. And then seeing how the technology has evolved across it and how medical device and security is really now becoming more important within the regulatory frameworks that we are seeing. I know there's been an emphasis on, the safety and effectiveness, but it's also, I hear more and more on the security of it as being integrated in. So I've been pleased with it and actually, one, learning, but, hearing the effectiveness is important.